Hello everyone, I am MG Sri Harsha and I am going to be presenting my artificial intelligence project, that is Sequential Specialist MoE routing architecture for complex queries. So the introduction is, and the problems we are facing are: the large language models which are being used today are very generalist and they are quite often very large. For example, some are 20 billion, some are 70 billion, and many reach 100 billion. The problem with this is, to train those models it is extremely expensive, and you need multi-cluster GPUs and all that to train them, and it will still take thousands of hours to train it. And the capacity you get from them is to answer complex queries, but I think that you don't need to train such a big model to answer such complex queries which are multi-domain related. And I have developed some algorithm which I think can solve this problem by using smaller expert only and give uh, output as good as a large generalist model. As I said, expensive training and inference cost, bad memory management. It takes a lot of large models which are dense, take a lot of VRAM. And my alternative, which I'm suggesting, is sequential specialist MoE routing architecture. And as it is obvious, our goals are to reduce training time, maintain performance, and modular architecture which is easy to edit with. And for my example, to showcase my routing architecture, I have used three specialists: Quen 2.5 family only, 1.5 billion for math, zero point 0.5 billion for both instruct chatting model and coder each. And stage one for my routing algorithm is loss based expert selection. So as you can see in the image, when there are n experts, all of them get full query, and those with the best loss get chosen, and those relevant experts are then assigned a query after further loss calculations. And generation pipeline is as follows: after query segmentation is done and each expert is assigned their query, expert 1 starts with its split query. It generates an output, and that output is given to expert 2 along the split query of expert 2, and this continues. Expert 2 output is given to expert 3 alongside split query expert 3, and then after n experts final output is generated. Evaluation in my testing. So I have compared a dense model Quen 2.5 VL3B, which is 3 billion parameters, to my MoE router model with the given experts as I have mentioned in this slide. Benchmark is 50 PhD level questions, 25 are maths questions, 25 are CS questions, and I have asked them to solve, explain, and code for every each question. And grading is done on 0 to 10 scale across. Results. As you can see, my MoE routing architecture didn't quite beat it, but came very close in solution and explanation. But there's a quite noticeable gap in coding part, since my coder is quite small, only 0.5 billion with these 500 million parameters. The evaluations were done by AI using same prompt for both 3B and for MoE architecture, so I think they're quite trusted. And with this, I want to conclude that my routing system shows promising results, and it would be good if we try to develop this architecture well. We can train experts in such a way that they are good at collaborating. We can use natural language processing for query segmentation instead of reject, which I used. And if we implement even these two, I think we can cross a dense model or at least compete equally. Thank you. In order to use this model, you just have to open use Jupyter file, just have to click run. You can use any virtual environment if you have, or a global environment if it works. And after a certain time, it will ask you to type a question. You can type any question you like. For example, and it will start processing. You can see all the losses for every query, like loss for solve, loss for explanation, and loss for code. And this native thing I used because sometimes wrong experts were being picked because of fine tuning, uh, overtraining. That's why this will help you to pick the correct expert. And mm, in order for the other expert to win, they have to cross a certain threshold. So it means that they are good enough for that, even though they are not specialized for it. And after a while, you'll get the answer as answer, the calculation part, explanation part, and then code too. So this is how you use this Jupyter file. Thank you.